Hello everyone. Today we are going to start a new topic, square and square roots. So first of all, we should know what do you mean by the square of a number and what do you mean by the square root. Then we will take the certain properties based on the square of a number one by one. So first of all, we should know what do you mean by the square of a number. A number that is multiplied by itself is known as square of a number multiplied by itself. So there is a notation how we write the square of a number. Suppose let a number be x, so we will write a 2 over 8. So this 2 represent, this exponent 2 represent the square of a number. It means a times a. We are multiplying a number with itself. Suppose we have 3 square, so it means we are multiplying 3 with 3. So this means the square of a number, that will come as 3 times 3 is 9. So that is the square of a number. And square root is just opposite of the square of a number. Here right now I am just giving the definition of the square root. We will take the properties later on. So what do you mean by the square root? The square root is that number is multiplied by itself to get that number. Suppose we have like this. So this is a symbol to represent the square root 9. So we will check a number when it multiplies itself gives 9. So here clearly we can see 3 is a number. If we multiply 3 with 3, it will give us a number 9. So it means 3. The square root of a 9 will be 3. So there are the certain methods to find out the square root that we will take later. First, concentrate on the square of a number and its properties. So first of all, let's take the square of the first 9 natural numbers. Like 1 square, it will give us 1. 2 square, 2 times 2 will give us 4. 3 square, it gives us 9. 4 square, it gives us 16. 5 square, 25. 6 square, 36. 7 square, 49. 8 square, 64. 9 square, 81. Let's take 10 also. 10 square will give us 100. So you can observe the certain things in the square of a number, like every number. First of all, we will see what is the unit digit of every square. Here, this is a single digit number, so 1 is the unit digit. 4 is also the single digit, so it's a unit place. We have 4, here we have 9. In 16, 6 at the unit place and 1 as the 10th place. So we have 6 at the unit place. So we will concentrate only on the unit place. Here in the 25 we have 5. In 36 again we have 6. In 7 square we have 9. In 8 square we have 4. In 9 square we have 1. And in 10 square we have 0. So we can say that we have only 1, 4, 9, 6, 5 and 0 on the square of the number. So we can say that the number that end with these digits like 1, 4, 9, 6, 5, 0, they can be the perfect square of any number. Like if we have 1, 2, 1. So here in unit place we have 1. So we will check. In here we have 1 square as a 1 at the unit place, and again in the 9 square we have 1 at the unit place. So we can say that 121 can be the square of any number. We cannot be sure, but it can be. There are the chances that the number ends with and that have the 1, 4, 6, 9 at the unit place, that can be the square of any number. So here we know 11 times 11 will give us 121. So this is the square of 11. it is possible that the number ends with 9, like 190, the number ends with 9, but here in the 3 square we have 9 at the unit place. Similarly, in the 7 square, in the 49, we also have the unit place 9, but here 190 has 9 at the unit place, but this is not the square of any number. So we cannot be sure, we cannot be 100% says the number that have unit place digit like 149650 will have, must be the square of a number, but there are the possibility. But the number ends with or that have at a unit place like 2, 3, and other than that here 7, 8, they are surely not be the square of any number, will not be square of any number. Like if we have any number, like if we say like 1, 2, 3, 4, 8. So in that case, what we will do, first we will check the unit digit. In the unit place we have 8, so it will not be or it cannot be the square of any number. Later we will see how to find out the given number is the square of which number. But here I am telling you the possibility to check whether the given number can be the square of any number or not. And for us it will be easy to tell what will be the unit digit of any square of the number. Like if we have 234 and we have to find out the square of this number, and we have to tell only the unit place of the number. So instead of finding out the square of a number and then tell, so we can find it out. A number ends with 4 always have 6 at the unit place, because the 4 square is equal to 16 and that have 6 at unit place. So a number ends with 4 always have 6 at the unit place. Similarly, if we have a number like 73, if we have a question like what will be at the unit place of the square of 73, so first of all we will find out the unit digit of the 73, that is 3, and we know 3 square will be 9, so it will always end with 9. On the 73 square surely will have 9 at unit place. And opposite of that, what we can say, if we have a number like 289, here we will see the unit digit of the number. Here we have 9 at the unit place. So it can be the square of a number that end with 3 or 7, because we know 3 square will give us 9 and 7 square will give us 49. That will have 9 at the unit place. So we can say 3 or 7 can be at unit place of a number whose square is 289. Suppose we have a number like 144. So it will have what will can have 2 or 8, because 2 square is equal to 4 and 8 square is equal to 64. Both have 4 at unit place. So it can, the number must be end with 2 or 8. Similarly, if we have like 256, so at the unit place it must have 4 or 6, because 4 square is equal to 16 and 6 square is equal to 36. Both ends with 6. So we can guess so what can be at the unit place of the number that end with number like 9, 4, 6, 1 also. So for the 1 we can guess it must have 1 at the unit place. Next we will see either the given number is a perfect number, perfect square or not, and then we will see how to find out the square of a number, or the number is the given number is the square of which number by the prime factorization method. So first of all we should know what do you mean by the perfect square. So a perfect square is always expressed as a product of pairs of equal factors. Suppose we have a number like 576, then we have to find out either it is a perfect square or not. Then first of all we will find out its prime factor. If they are in a pair, then it can be the perfect square, otherwise not. So by prime factorization, how to find out the factors? What we will do? We will find the smallest number by which we can divide 576. Clearly 576 is an even number, so we can divide it with 2. So the remainder, the quotient what we left with is 288. When we divide 576 by 2, we get 288 as a quotient. Obviously remainder will be 0 only. Then 2 again, because again it's a even number, then we will get 144. Again it's an even number, so again we will divide it by 2 only. Then we will get 72. Then we will divide with 2, then we will get 36. Then 2, we will get 18. Then 2, then we will get 9. Here we left with 9. So the smallest number the 9 can be divisible is 3. We will left as 3, and we will carry forward until we will get a prime number as a 1. So here now we'll start making the pairs. So here we have 2 in a pair, again we have 2 in a pair. Here again we have 2 in a pair, and here we have 3 in a pair. So we will write down pair as a single number. So here we have one pair of 2, so we will write as 2. Then multiply. Here again we have 2 in a pair, we will write 2. Here we have one more 2 in a pair, we will write 2. Then we have 3. So now we will multiply these numbers. So we will, how we multiply? 2 times 4, 8. 8 times 3 is 24. It means 576 is a perfect square of 24. So this is the way how we find out the square, perfect square by the prime factorization method. Or we will check whether the given number is perfect square or not. Let's take one more example. Suppose we have 1176. So again, being an even number, we will start with 2 only. So what will be left with? 588. So here we will get 294. Again we will divide by 2. We will get 147. Then the 147 can be divisible by 3. So we will left with 49. Then we will divide it by 7. Here 7 again, then we will left with 1. So let's make the pair now. Here we will get 2 in a pair. Here we get 7 in a pair. But here we left with 1 2 and 1 3. That cannot be pair out. So it means 1176 is not a perfect square. So this is the way we will check either the given number is perfect square or no, or we can say this is the prime factorization method. And in perfect square we have one more property, like square number can have only even number of zeros at the end. Means square like 10 square will give us 100. So it has even number of zeros. If we take out the 100 square, so 100 times 100 will give us 4 zeros. Again it has even number of zeros. Let's take the 1000. So we will get 6 zeros. So it means the square of a number that ends with 0 always have the even number of zeros at the end. So based on the properties that we learned today, let's take some examples over it. So the first example is, so in this we have given three numbers 5625, 4225, 1089, and by using the prime factorization method we have to find out either they are the perfect square or not. Let's start with the first number 5625. So clearly a number that ends with 5 always divisible by 5. So the smallest number will be 5. So when we divide 5625 by 5, what we get it? 1, 1, 2, 5. Again when we divide it with 5, we will left with 10, 10, 5. 2 to 5. Then again we will divide it like with 5 only. Then we will get 45. And then again we divide it with 5. We will get 9. Then 9 is divisible by 3. We will get 3 over here and 3. Then we will get 1 over here. So what we have? 5. 4 times 5. Then we have 3. So let's make out the pair. 1, 2, 3. So we will write as it 5. Second pair 5 and the another pair is 3. So now let's multiply. 5 times 5 is 25 and 25 times 3 is 75. So 5625 is a perfect square of a number 75. The next number is 4225. Let's start with dividing it by 5. Then we left with 8, 4, 5. Again 5 we will left with 1, 6, 9. So here the smallest number that we can divide 169 is 13, and we left with 13 over here. 13 times 1 is 13. So we have a pair over here. Here is a one pair of 5 and here is a one pair of 13. So we will left with 5 times 13. It will give us 65. It means 65 square is 4225 is the perfect square of 65. Next number we have 1089. So we will start dividing it by 3. So here we will left with 363. Here we will get 121, and the number that can divide 121 is 11. Here we will get 11. Here it will be 1. So let's make out the pair. 3, 11 and 11. It will give us 1, 3, and this pair will give us 11. So it means 33. 1089 is a perfect square of 33. This is the prime factorization method. Next question we have like, find the smallest number by which the given number must be multiplied so the product is perfect square. So clearly from the question we get the number like 23805 and 12150 are not the perfect square. So we have to find out the smallest number by which we can multiply this number and it will become the perfect square. So what we will do, first of all we will start making the pair by using the prime factorization method, and the number what will be left out we will multiply with that number. So let's start the prime factorization method with 23805. So let's start by dividing it by 5. When we divide it by 5, what we will get? 4, 7, 6, 1. Then this number is not divisible by 5. This number is divisible by 3. So what we will get over here? 1, 5, 8, 7. Again this number is divisible by 3. We will get 5, 2, 9. And this number is divisible by 23. So this thing we have to figure it out, but the smallest number by which we can divide the number. This is 23 and we will get over 23 over here. So we will get the number like 5, 3, 23 and 23. So now let's start making the pair. Here we will get 3. Here we will get 23. But clearly here 5 is not in the pair. If we multiply, if we have one more 5, then it can be the perfect square. So what does it mean? We have to multiply by 5 so that it will become a perfect square. And it will be perfect by which number? If we multiply by 5, again we will have 5 in a pair. So we will get 5 over here. So we will get, when we multiply this number, we will get 345. So the product is the square of 345 if we multiply it by 5. So now what we have to do? We have to multiply 23805 by 5 and the new number will be the square of 345. Clear? Similarly, we will do the next question. We have 1, 2, 1, 5, 0. So let's start the prime factorization. So let's start with 2. We will get 6, 0, 7, 5. Now we will divide it by 5. We will get 1, 2, 1, 5. When we divide it by 5, we will get 243. So this number divisible by 3. So we will get 81. The next we will get 27. Next we will get 9. Then we get 3. Here we will get 3. So what we get from here is 5 in the pair. So we will write 5 over here. Then 3 in the pair. We will write 3 over here. Then we have 3 in the pair. So we will write 3 over here. Then we have 1, 3 and 1, 2 that are not in the pair. So from here what we will get? 5 times 3 is 15. 15 times 3 is 45. And here we don't have 3 and 2 in the pair. It means we have to multiply 1, 3 and 1, 2 so that it can be pair and the number can be the perfect square. And 3 times 2 will give us 6. So it means we have to multiply 12150 by 6 so that it can be the perfect square, and it will be 6 times 5 is 30, is 270. So it means if we multiply 12150 by 6, we will get 270 square. So this is the method how we will get by which number we have to multiply. So it means first of all we will find out the prime factors, and by the left out prime factors we will multiply the given number to make it the perfect square. Next we have to find out the number by which we can divide the given number to make it a perfect square. In the previous example, we saw which number we have to multiply. In this, we will see which number we have to divide. The process will be same. We have to find out the prime factors. Then the left out factor, we will divide it. In the previous, we multiplied by the same factor. Here, we will divide it. So let's start with the 776. So let's find out the prime factors. So when we divide it by 2, we will get 3, 888. Next we will get 1944. Next we will get 972. Next we get 486. Then 243. Then we will get, sorry, it will be 381. Then we will get 27. Here is 9. Here is 3. And here we will 1. Then let's make out the pairs. Here what we get, one pair will give us 2, another pair will give us 2. Now this 2 is left over. This pair will give us 3. Again this pair will give us 3. Now so we have left out 2 and 3. So it means if we divide this number by 6, or we can say by 2 and 3, we will get the perfect square. And the next number will be the perfect square of 2 times 2 is 4, is 12, 12 times 3 is 36, because here we have to divide. The next number will be the perfect square of 36. So we will divide by 2 and 3. Next number we have 8820. So now let's start dividing in by 2. We will get 4410. Here we will get 2205. Here we will get 5. We will get 441. Next 3, 147. Then we'll 3, it will give us 49, 7, 7, and then 1. So now what we will have, 2, then we have 3, 7, and we have 5. So it give us 2, it give us 3, it give us 7, and the 5 is left out. So it means we have to divide it by 5, because 5 divided by 5 will give us 1. So if we divide this number by 5, we will get the new number. The new number will be 3 times 2 is 6, 6 times 7 is 42. It means we have to divide the number 8820 by 5. It will give us the square of 42. Next question we have to find out the smallest number, smallest square number which is divisible by each of the number 9, 8, 12 and 15. So we have to find out the smallest number. So in that case what we will do, first of all we will find out the LCM of the given number 9, 10, 12 and 15. Let's find out the LCM of these 4 numbers. I hope you all know how to find out the LCM, but here I am doing. So the smallest number I am taking over here is 2. So let's take out the number which is divisible by 2, and the number that are not divisible, just write it same. Like 10 divided by 2 is 5, 12 divided by 2 is 6, 15 is not divisible, so we will write 15 only. So the next, let's take it 3. So 9 divided by 3 is 3. Any other number are not divisible. Oh yeah, 6. 6 divided by 3 is 2. And 15 divided by 3 is 5. Sorry, there are many numbers that are divisible by 3 over here. So again 3, 1, 5, 2, 5. Then we can take 5, 1, 1, 2, 1. So the LCM of the 9, 10, 12 and 15 will come as 2, 3, 3, 5 and 2. Here we left with the prime number is 2. So the product will give us 180. So it means 180 is the LCM of 9, 10, 12 and 15. Now we have to find it out either 180 is a perfect square or not. So for that, what we will do, we will prime factor 180. So what we will get, 290, over here we will get 45, here we will get 3, then 15, 3, 5, then 5, 1. So in the pair we have 2, and another pair we have 3, and then we left with 5. So it means 180 is not a perfect square because we left with 5. Now this number is either divided by 5 or multiplied by 5 to make it divisible, to make it a perfect square. So here we are multiplying it by 5, so we will have a perfect square, so then it will be the perfect square of 30. So it means we will multiply 180 by 5 to get the perfect square. So hence the required number is 900, that is divisible by each of the number 9, 10, 12 and 15. In another way, if we divide 180 by 5, we will left with, if we divide 180 by 5, we will left with 36, and clearly 36 is not divisible by 10. So but here we have to find out a number that is divisible by each of the number 9, 10, 12 and 15. So here we are multiplying that number by 5 to get the number that is perfect square. So in today's lesson I cover the square of the number, how to find out, to check either the given number is a perfect square or not by the prime factorization method, and we saw some of the properties of the square also. I hope you got everything, how to find out the perfect square, how to do the prime factorization, and how to divide a given number, or how to multiply by which number we have to multiply, and how to find out the pairs of the number. But still, if you have any doubt, you can reach out to my comment section. And if you like my videos, please don't forget to like, share and subscribe. Till then, thank you.